Okay, so we're picking back up where we left off. We had that very last piecewise example, and I want to show you how that one works. So in very much the same way as the last problem, we want to choose values, x and y, 3 of them at least on each of the pieces. On this one in particular, 2 would be enough because we do have 2 pieces that are actually both lines because of the way that this particular problem works out. It has a special name. It's actually called piecewise linear as well. You don't need to worry about that, but it does have that name because both pieces are linear. So this one actually tells me I need values that are before 2 and after 2. That's what it says. So I need to pick 3 values before 2, so maybe like 0, 1, and 2. That works really well. And then on the next one, while I don't actually have the ability to pick 2, I want to see what happens at 2, because what I really have happening at 2 on the second graph is a hole in my graph. So I'm going to pick 2 and figure out where that open circle is. And then 2 values bigger than 2. So maybe I pick 3 and I pick 4. And we might adjust these. You don't necessarily have to pick these specific values. 0 works really nicely in the first equation because 3 halves times 0 is 0. 2 minus 0 would be 2. 1 is not quite as friendly, right? Because now I have 2 times 1 minus 3 halves, or 2 times, the 1 times the 3 halves is where I have my 1 plugging in. So 2, which would be 4 halves, minus 3 halves would be 1 half. So I'll write it in. But if you don't want to use fractions and you'd like to make a different choice, instead you could choose something different. If I pick the number 2 to plug in, the 2 times the 3 halves would actually give me a negative 3, because the 2's would cancel. So then I have 2 minus 3, which is negative 1. So once I switch to the other set of values, the 2, 3, 4, I'm looking at the second equation because I'm looking at values that are bigger than 2. Now I realize that 2 itself is not, so I'm going to get an open circle at that one, but I need that open circle present on my graph. So that 2 plugged in would give me 3. So I have an open circle, and I'll just write it on here to remind myself at that value. If I plug in 3, 3 plus 1 is 4, and 4 plus 1 is 5. So we're going to plot these points now on our graph. We actually plotted values to the right, but 1, 2, 3, and 4. And we had values that extended down from negative 1 up to positive 5. So that looks pretty good. I have 0, 2. So x is 0, y is 2, looks like that. X is 1 and y is 1 half, looks like this. And then x is 2 and y is negative 1 would be down here. And then on my other one, where it's a 2 but an open circle, it's an open circle at 2, 3. So it looks like this. So we have an open circle at 2, 3. And then I have 3, 4. And 3, 5. Let me shift my numbers over for now. Whoops, didn't quite catch them all. Let's try one more time. Oh, that's close. Okay, there we go. So the last one was 4, 5, which would be right here. Okay, so I can only connect the pieces that are to the left to the right. So if I did the first 3 pieces, those are connected, and like I mentioned earlier, they are connected in a line. So I have this line that connects these 3 pieces, just like that, and it continues on. The other also have to be connected, right? It went from 2, 0, 2, 3, that open circle at 2, 3, and to the right like this. So this is actually what my graph looks like, and you'll notice for the first time I actually have an open circle present on my graph that didn't get filled in. I had one last time on number 12, but it got filled in. So like on the other ones, my domain actually still is all real numbers. Now, so certainly you would say as I move from left to the right over here, it works until I get to 2. I have a jump in my graph at 2, but even though I have the jump in the graph, I don't miss any of the x values because I stop at a 2 and I start back in an open circle at 2. So my domain is still negative infinity to infinity. My range actually starts then down here as I'm climbing the y-axis at negative 1. And as I climb up, there's a place where I actually see more than one part of my line, but I don't ever stop seeing parts of my line. So my range is actually negative 1 to infinity as well. Now suppose for a moment that this graph, instead of being here, had been down here. So indeed on part of the graph, actually that's not what I wanted to do. Let me change that. Let's say that instead of it being here, it had been down here like I was about to do, but it were pointing downward instead like that. So there really was a gap here, right? So there's this gap right here in the y-axis. So if that were the case, I would actually have my range starting at negative infinity and going up to the open circle, and I'd put a parenthesis on the open circle, and then I'd pick back up wherever that open circle's value is, say maybe it's negative 4. And then I'd pick back up at y equals 1, and I'd go up from 1 to infinity. Okay, so that is a possibility of an adjustment for how that might look. As I'm moving from left to right, initially it is decreasing. It is decreasing from negative infinity until I get the x value of 2. It is increasing from the x value of 2 then on to infinity, and it does not have any pieces where it's constant. Okay, so this is a piecewise linear. I do have the pieces where they don't connect on this one. That open circle, depending on where it is, and that jump, depending on where it is, might in fact affect the range or even the domain, depending. And it might affect the parentheses or brackets on those pieces if I were to have that happening too.